this. Let's see. So yesterday we did like most of the CRO, and then I hope you guys understand this. If you have any questions about it, do let me know. Okay. So today we're done with Doppler effect, we're done with CRO. Now today we are going to start with electromagnetic spectrum. For electromagnetic spectrum, I just want to tell you that they have some common property that makes these waves a spectrum. So all waves in it are transverse. Number two, they all travel at 3.0 times 10 raised to 8 meters per second in vacuum or air. Number three, they do not require a medium. Number four, they can reflect, refract, and diffract. So they can cause all, they're just waves, so they follow everything what waves can do. All right. Now, unfortunately, in this chapter, they require you to remember their wavelengths. Okay. So, you will learn their types, write the name, we're gonna write the symbol, and then we're gonna write the wavelength. Okay. And then we will write their individual, uses and stuff. Okay. In fact, we'll write the uses right here. I don't need to, Let's do that. So the first one that we got is radio wave. Radio wave, generally we write it as this. The wavelength of a radio wave is 10 raised to power 4. Okay, we write it like this: 10 raised to minus 1 to 10 raised to 4, or longer. So they can be quite long, right? All the wavelengths will be given in meters, by the way, so you guys can remember that. The uses of radio waves are long distance communication. Number two, they're used in astronomy and basically study of space. And they are also used in RIFTs. IFTs are basically radio frequency identification. They're basically uh, objects which are tagged and tracked. For example, if you go by something like if you go by something like clothes from a physical store, you might see that they have certain tags on them. That when you buy them, they remove those. Otherwise, if you try to exit the store with the tag on, it would sound the alarm. Have you seen that?
Yes.
All right. So those are RFIDs. One of the advanced form of RFID is Apple Tag, AirTag. Sorry, AirTag. But AirTag doesn't use radio frequency; it uses microwave, Bluetooth. But it's similar thing. All right, everyone. I hope you guys can understand that. Okay, then. The next thing is the next wave is the. Let's write it here. Oh, no. The next wave is the microwave. Microwave has a range of 10 raised to power minus 3 to 10 raised to power minus 1. So it's much shorter than, radio wave. Now, microwave can be used for a couple of things as well, like, say, cooking, satellite communication in both the television and mobile phones, something like that, right? And they basically just remember that they can be bad as well. So I'm going to write the bad points, writing bad. Bad means negative points. Causes internal heating of body cells. So it's good that it should not be very much concentrated. Otherwise, they do no harm, but if they concentrate, they might. Now comes infrared, IR, and infrared is 10 raised to power minus 6 to 10 raised to power minus 2. That could be like that. Now, infrared has certain uses as well. Like infrared can be used in electric grills. It can be used in remote controllers like TV remotes or your Xbox remote or whatever. It's used in intruder alarms because it can detect a heat is this any heat sources infrared. It's also used in thermal imaging and also optical fibers can be used in that too these days. The bad part about this is that, sorry, I had to write it with green. It can cause burns because it is quite hot, that's why. Okay. I hope that's clear. Now comes visible light. Invisible light is like no symbol really. Um, we just write light for this. So this is the most important range that you remember. 4 into 10 raised to power 7 to 7 into 10 raised to power 7 meters is the range of this itself. So it has its own range like that. And the so it's very it is used to see objects, of course, and in photography. So that's how illumination maybe. So it has no use except for the big one that you can see. I hope that's clear. Now microwave, sorry, after visible light we have ultraviolet. For ultraviolet we write UV. Ultraviolet is between 10 raised to minus 7 to 10 raised to power minus 9. And basically ultraviolet is used for security marking, tanning beds, detection of fake currency, so basically that, and sterilization of water, sometimes that's also used. The thing about this is, which is bad, is number one, it does cause damage to cells and eyes. So snow blindness is a common one. It might lead to skin and eye condition as well. Like if you do not put ultraviolet, ultraviolet screen or something like a sunblock, it might cause you, that kind of bad patches and stuff. And eye should always be protected from, especially if you go in snowy areas. It can cause snow blindness. Okay. Now, the next two are basically the radioactive ones. So first of all, we have, let's write it from here. We got X-rays. X-rays are basically from 10 raised to power, just written as X-ray. 10 raised to power minus 9 to 10 raised to minus 12. And X-rays basically have two major functions. Number one, medical scanning. Number two, security scanning. A lot of airports use this, and you also can take images of a broken bone or something like that. The thing is that this is radioactive, which means that it can cause mutation and damage to body cells. So you guys need to take care of it. Okay. Then number 7 is the gamma rays. Gamma rays symbol is like a ribbon like this, and gamma rays can be 10 raised to power minus 10 to 10 raised to minus 16 or shorter. So they can be even shorter wavelength from here. Gamma rays have a couple of uses, like sterilizing food can be used in that, sterilizing medical equipment because it can actually kill all living cells, and detection and treatment of cancer, so it can do that. But also this is also radioactive, which basically means that it can cause mutation and damage to body cells. So that's also something bad about them. Alright, if you guys have any questions here, please let me know. Javeria, Aman, Hamad, Aisha. Any question really? Okay. Right. Now, if you look at what we've really achieved so far, is that these waves, okay, so we not only need to remember the wavelengths, okay, which is for fact, unfortunately, we have to, but also the series, like the series is starting from radio, then it goes to microwave, then it goes to infrared, then it goes to visible light, and from visible light, ultraviolet, X-ray, and gamma. So if you go in this direction, basically from radio to this, you guys need to remember that the wavelength reduces and frequency increases. However, they have the same speed in air, so you can always find v is equal to f lambda. You have the speed of a light, which is 3.0 and 10 raised to 8. You can always find the frequency if you know the wavelength, so do not worry about that, right? Now itself, visible light has its own spectrum. We'll learn that. Like for example, when white light, which is basically just the normal light, enters into prism, it basically releases red, and then it also releases violet. Okay, and five more colors between them. Like after this, it releases orange, then yellow, and it actually starts dispersing the light from the point where it enters. Then green, and then blue, and also indigo, like that. Okay, now what you guys need to remember is that this is the path. Like it has red, orange, and then yellow, green, blue, indigo, and violet. Okay, now we also need to remember their wavelengths in meters. In fact, I'll write it in nanometers, because usually they give in nanometers. So red is about 700 nanometer, orange is 625 nanometers, yellow is 590 nanometers, green is about 500 nanometers, blue is 480 nanometers, indigo is 450 nanometers, and the last one is the shortest wavelength, which is 400. So you got to remember that. Again, if you go down here from red to indigo, the wavelength basically is reducing, frequency is increasing, so you got to remember that. And if you look at their position in the spectrum, right, so you'd realize that basically before red, like you have infrared. Infrared means that basically it is inferior to red, and after violet, in the position of the whole spectrum, it is ultra violet, like that, you see, and then the other way. So this is, all of them basically constitutes visible light. Is it clear, everybody?
Yes.
Okay, that's good. Right, you can write this down, please. Right. Okay. Acha. So okay. All right, so now I'd like to give you a worksheet. All right, and then next week when you come, I'm going to check that worksheet and we'll finish this topic with this small one where it's basically just the part where polarization needs to be discussed. So